What is page fault? Okay, when CPU decide to execute a page, that page is now not there in the main memory, but it is in the secondary memory. We call it as page fault. When the CPU is going to execute some program, the program should be there in the random access memory. So executions are starting from the random access memory. From the RAM fetches the data and instruction to the control unit and ALU. Okay. For that, all the pages, the programming file should be there, paging file should be there in the random access memory. But if the paging file is not there in the random access memory and it resides in the virtual memory, we call it as page fault. Map absent. It is not mapped to the random access memory. So it is absent in the random access memory, but it resides in the virtual memory. And execute stuck there. So program is waiting until the paging file coming from the virtual memory, but can't because it is not, there's no frame number to carry the file. The paging file is there in the virtual memory. Therefore, have to send a special command to the virtual memory to release that file, paging file. Then only can execute. Okay. So this situation we call, if the demanding paging file is not available in the random access memory, we call page fault. So when CPU decide to execute a page mean actually paging file. Okay, paging file. That paging file is not there in the main memory, but it is there in the secondary memory. This should be paging file. Okay. Whereas pages are in the virtual memory. Okay, pages are not moving. Paging file is the one which is moving. Okay, so that paging file is not in the is not there in the main memory, but it is there in the secondary memory, mean virtual memory. Virtual memory. This is called page fault. So demanding page is not present in the main memory. Demanding paging file. But if you Google it, you can find that is demanding page. But actually it should be paging file. Huh? So if that is not available, now look at this one. CPU is going to run, then there's no paging file, then have to take it from the virtual memory. So send a command to take it back to the virtual memory. We call it as page fault. No need too much, just to know if the file is absent in the page table. That means the file is paging file is reside in the virtual memory. We call that as page fault. Okay, we'll copy down this one. Change this one as paging file. Execute page within bracket paging file. එහෙම කරමුද? මේක දැන් කෙලින්ම print screen එකක් ගත්ත එක. When CPU decide to execute a page, it should be paging file. Write it as paging file. Huh? No need to write the page. Write it as paging file. Is it necessary to load an entire program to random access memory for execution? Yes. Or the program has to be in random access memory for execution. Why? Can you remember 7-state diagram? In 7-state diagram, running, execution, running was there in the random access memory, not the virtual memory. Okay. So if the size of the if the size of program is larger than the available RAM memory, how can it be executed? So virtual memory allocates the required memory space for it and map to the random access memory for execution. We'll write this one. Okay, this is which I use for the revision. Copy that answer. No need to write, just look at virtual memory is partitioned into equal pages. Random access memory is partitioned into equal size frames. Size of the page, size of the page frame program are also partitioned into the page at the time is logging. So program also partitioned into same sizes. Then paging file size equal to frame size equal to page size. For the process runs the virtual machines as defined as underlying hardware, focus on the hardware support virtual address space, virtual address independent of the physical memory. So virtual address means a hard disk address, and that means virtual memory address. Physical memory address means random access memory address. So those are working independently. So key hardware components of the memory management unit are there. So address translation, virtual address to physical memory address, and ensure the address space protection. This on last point is a little bit important. Key hardware components is the memory management unit. So memory management unit address translation is there, and ensure the virtual address space is protected. So I think we discussed this one earlier also. Address translation, virtual to physical memory address translation, and virtual memory address space protection is there in the memory management unit. If you haven't written, then you can copy it. Memory management unit, address translation, and ensure the virtual address space protection. If you want, just check whether you have written this one. Memory management unit, address translation I gave. And the last point, virtual address space protection is there. If it is not there, then write only the last point under the MMU. කලින් note එක ලියලා නැත්තම් functions of the memory management unit, address translation, virtual address to physical address, physical memory address, and it ensures the virtual address space protection. Okay. Virtual to physical memory address translation file. Copy that. Virtual memory serves two purpose. Functionalities are there, allow to extend the use of physical memory by using the hard disk. Then it allows us to have memory protection because virtual address is translated to the physical address. That is mapped with the random access memory address. Okay. Copy this one. Virtual memory goals allow applications larger than the physical memory to execute. Run partially load programs. Entire program need not to be in the memory all the time. Entire program is now need to be in the random access memory in the all the time. Once it is required, can take from the virtual memory. No need to be every time in the RAM. Okay. If the space is not there, it can be reside in the virtual memory. Degree of the multi-programming, many programs simultaneously reside in the memory. Applications should not be managed the memory resource. Program should not depend on the memory architecture. Permit sharing of the memory segment or regions. For example, read-only code segment should be shared between program instances. So can sharing the file while executing also there. We'll copy down this one. Okay. Mainly 3 points are enough if you can remember, but we'll copy it. I think. First 3 points are okay. Copy all.